in the previous video, we have seen system pole and the input pole. We have defined both system pole and zero and the input pole and zero. So in this video, we will understand the effect of these system pole, input pole on the response of the system. So the response of the system is given by P of S is equal to T of S into R of S, where T of S is given by, we will consider the same system, s plus 2 divided by s plus 5 plus 2 divided by s plus 5 into r of s is 1 by s. So now in order to find out the system pole, we need to partial differentiate this. So when we partial differentiate this, we get 2 by 5 by s plus 3 by 5 divided by s plus 5. So now, so this, when you take Laplace inverse of this function, when we take Laplace inverse, so what we get is 2 by 5 plus 3 by 5 e to the power minus 5t. This is the Laplace inverse of the function. Now here we can see that the response can be differentiated into two components. There are two terms here. So this is one term and this is our second term. Now here you can see that the first term is a constant. It's a constant. Whereas second term is an exponential term. We have an exponent value e to the power minus 5t. So it is an exponential term. Now coming to the types of responses that we've seen in the previous videos. So this 2 by 5, we term it as forced or steady state response. And the second term, we call it as natural or transient response. Now the reason why we call this forced response is because you can see that, we'll get back to this equation. We have this first term and we have this second term. Now what is the pole of this first term? The pole is at s is equal to 0. Similarly here, the pole of this function is s is equal to minus 5. We've seen in the previous video that s is equal to 0 is the input pole and s is equal to minus 5 is the system pole. So we can see that. So this is input pole. S is equal to minus 5 is the system pole. And we can see that this term, the first term, is giving us what is called as the forced response. So we can infer from this that the forced response or the steady state response is dependent on the input pole. Okay, so your steady state response will always be determined by what type of input you are giving. So if you give, we've seen that in the previous class, in the previous recordings, that this used to be our C of t value. And at steady state, it used to attain 1, that is the final value. And 1 is nothing but the input that we had given, that is u of t, unit step input. So always the steady state response is dependent on what type of input we are giving. And we can see that the system pole is s is equal to minus 5. And this is responsible for the natural or transient response. So s is equal to minus 5 is the system pole and that is giving us the exponential term. So the system pole will always determine the natural or transient response. So these responses will decay after certain time, and your input response or the input pole will dominate, and it will take over the entire response. So, inference from these two terms is that first thing, first one, the input pole generates the steady state response. Sorry, yeah, the steady state or forced response. And second inference is that the system pole generates the transient or natural response. So, if you change the input pole, or if you change, if you change the input pole, like if it s is equal to 0 is the input pole here, and if you make it s is equal to 1, so it will not have much effect on the exponential term, that is this term. It will not have a very big, it will not affect this exponential term. But there might be change in the amplitude. The 2 by 5 and the 3 by 5 amplitude can change. That may vary. But this term, the exponential term, will remain same if you keep the system pole as it is. When we change the system pole, this exponential term changes. If you take s is equal to minus 2, so this becomes e raised to minus 2t. So this term changes. Always the exponential term is dependent on this system pole. Any change in the system pole will change how fast or how fast the system will decay out, or how fast the system will reach the final value. The exponential term is the measure of how fast your system will respond. So your system pole is one which will decide how fast the system will respond. Whereas input pole will have no effect on the time taken by the system. The time taken by the system is entirely dependent on the system pole. Input pole has no effect on the time taken by the system. Whereas coming to the amplitudes of both the input, this function is dependent on both system pole, input pole, as well as the zero. The zero comes into picture here. Okay, the zero is mainly dependent on what type of what is the amplitude, how big is the exponential term, what is the amplitude of the exponential term, what is the amplitude of the forced response, that is dependent on the zeros. This is the first this is the third inference that we make from this particular analysis. So we've seen the first one, the pole of the input function generates the steady state response. The third one is the system pole generates the transient or the natural response. And then the amplitude is dependent on the amplitude of both forced and natural response is generated by poles and zero. You can't say it is completely dependent on zero. It is both poles and zeros of both system and as well as the input pole. Thank you.